2.1 Set Concepts. So set A is a collection of objects which are called elements or members of the set. So there's three ways to describe a set. It's description, which is using words, roster form, and set builder notation. So well-defined set. A set is well-defined if its contents can be clearly determined. It's not biased. So an example of a well-defined set, the set of US presidents is a well-defined set because its contents, the presidents, can be named. How about the set of best doctors? That is biased because what does best mean, right? How about everybody celebrating July 4th at Lincoln Park? That's well defined. I know everyone who's there. There can't be an infinite amount of people at a park, right? There's like those people who were there, that was it. So, moving on. Description of sets. Let's write a description of a set containing the elements January, February, March, April, May, June, July, August, November, December. I forgot October, but you get it, right? So what would we call those? Those are the months, right? So we would say is, change that color. The set is the months of the year. So we would probably say, oh yeah, that's the months of the year, right? But the new word we have to say is the set, because it's asking, right, a description of the set. So the set is blah, 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 blah. Okay. Roster form. Listing the elements of a set inside a pair of braces, those are those little squigglies, is called roster form. So if you see those little squigglies, you're talking about a set. They're kind of hard to draw. I'm not the best at them. See, I'm not that good. So you can try to do that. I see a lot of people just do like those types of squigglies, like a weird looking three thing. And then I had a student last semester when we were actually in school said, just draw a bird sideways. So like when you do the little like stick figure bird, turn it sideways. If you turn it sideways, if you turn your paper sideways, see? Isn't that amazing? I haven't practiced it, but that's just another way. Anyways, that's how you can say set. So if you see those little braces, those little squigglies, those are called braces, is the notation for the set whose elements are 1, 2, and 3. Parentheses 1, 2, and 3, brackets 1, 2, 3, those do not mean a set. A set has to have the braces, so the set has to have the braces. If not, it's not a set. Naming of sets. Sets are generally named with a capital letter, so natural numbers. The set of natural numbers or counting numbers is the set n equals 1, 2, 3, 4, 5, 6, 7, 8 forever. So counting numbers are we don't count 1.111, 1.112. We don't count that way. We count 1, 2, 3, 4, 5. So those are called natural numbers, or also known as counting numbers. Let's do roster form of sets. So express the following in roster form. Set A is the set of natural numbers less than 6. So it says set A. That means we have A equals the natural numbers less than 6. So we draw our little braces. The reason why we draw the braces is because it says roster form. So we draw the little braces and natural numbers less than 6. So that's 1, 2, 3, 4, 5. Because we want natural numbers less than 6. So normal counting numbers that are less than 6. Alrighty, set B is a set of natural numbers less than or equal to 45. So we're talking about set B now. And it equals the natural numbers less than or equal to 45. So less than natural numbers, you're always going to start at 1. So we have our braces. Wrong color. So we have our braces. We're going to go 1, 2, 3. Now, I'm not going to write 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all the way to 45. No, what we do is we do that little dot, dot, dot. And then it says, and less than or equal to 45. So since it says equal to 45, we're actually going to use the number 45. That's going to happen. Just get used to it. So just a little note here. If you're talking about less than or greater than, there's you don't use the number. I don't like that. And if it says equal to, you do use the number. I don't like making that one a note. Alright, so set P. This is just for pure entertainment for me. You're not going to have to know the planets. So set P is the set of planets in Earth's solar system. So for part C, we have set P and all the planets in our solar system. So it's Mercury, Venus. Did I spell that right? Nope, forgot that R. There we go. Venus, us, Earth, Mars, Jupiter, Saturn, Uranus. Yep, I'm a child. And Neptune. So, Pluto is not a planet. Do not try to argue with me, or I'm going to throw some facts at you right now. Alright, so, the reason why Pluto is not a planet is because, so back in the day when, like, Galileo and them were, like, figuring out, like, the solar system and stuff like that, there's this asteroid belt closer to Sun, and it's in between Mercury and Venus, and it's, like, there's, like, thousands and thousands and thousands of asteroids. So back then, they actually called them planets. So they thought that the solar system had thousands of planets when it doesn't. So what happened when Pluto changed from a planet to not a planet is just because our standards changed of what we call a planet. Like, what does it mean to be a planet? Our standards have changed. So it's like, what does it mean to be a human, right? We can change those standards. So that's what happened in the scientific community. They changed the standards of what a planet actually is. So that's why Pluto is no longer a planet. I know. Alright, moving on. You're going to get that all semester. Just imagine if we were in class. Alright, so set symbols. The symbol, that little E weird looking thing, it's said is an element of. So if you see that little E, it's red is an element of. And it's used to indicate membership in a set. The symbol with the little e crossed out means not an element of. So anytime you see that something canceled out, it means not, right? It's just like if you had an equal sign, right? That means equal. But if you had that one, it means not equal, right? All right, set builder notation or set generator notation. You're good. It's set builder notation. A formal statement that describes the membership of a set is written between the braces. A variable may represent any one of the members of the set. Alrighty, so let's use set builder notation. Write set B, 1, 2, 3, 4, 5 in set builder notation. I'm actually going to change my screen color to white. So if your brightness is way up, turn it down for a second because the screen's about to get really bright. There we go. I wasn't lying. Alright, so part A. So set B, so we have set B equals 1, 2, 3, 4, 5. What does that mean to us? So 1, 2, 3, 4, 5 means those are counting numbers. And we say counting numbers are natural numbers. So because it's in set builder notation, we do the little braces. And then the variable, we have to use a variable, so any variable, but we usually use x such that we have 1, 2, 3, 4, 5, meaning x is an element of natural numbers and x is less than 6. Because it's saying all the numbers are less than 6. So I'm actually going to write this out. That's what part B is saying. is to write this out in words. It's going to help us better understand. But we could also do another version of part A. So we could say set B equals x such that x is a natural number. So x is an element of natural numbers. And x is less than or equal to 5. Because we can say that because if it's 1, 2, 3, 4, 5, that's less than 5, but it also has that line underneath, so we can say end equal to. Okay, part B, I'm going to describe the first one we got. And I'm going to try and tie it all together. So, the set of all x, that part, that's what this is. Oop, you can't see that. My bad. See, you can see I love that color. So that's what this part is saying. It's saying the set of all x. Then we have such that. Such that is this little line. That's what that means. I'm sure you've seen it before in other math classes. It just means such that. All right, moving on. I forgot to. There we go. So next is x is a natural number. So what part does that represent? It represents this part right here. X is a natural number. And, that's self-explanatory, just means and. X is less than 6. All right, I'll kind of break this down a lot more for us. So the set of all x, that's just saying we have a set and x is what we're representing, whatever's in it. So x is a natural number. The reason why we have to say that, because if we don't say x is a natural number, we would have to say, well, the numbers could go, it says x is less than 6. That means we can go into the negatives. That means we can go 0, -1, -2, -3, -4. But the x is a natural number part, that tells us we stop at 1. We don't keep going. We don't go 0, -1, -2, because that is less than 6. It's telling us, nope, it's 1, 2, 3, 4, 5. That is it. Now we're going to do the opposite. We're going to write roster form, set builder notation to roster form. So this first part right here is just telling us we're using counting numbers. So it says counting numbers. So that's all that means. And then it's telling us to use numbers 2 through 8. But we have to look next to the 2. So next to the 2 we have this symbol right here. So that tells us we have to use the 2. That means we use that value of 2, because that's what the little bar means. That little bar means and equal to. So we're going to use it. So we have set A. Our first number is 2, and it's going to 8. So 2, 3, I'm not going to write it all. So next to the 8, we have this symbol. There's no line underneath. Since there's no line underneath, we go to the next number smallest, or the next smallest number. So it's 7. And there we go. So 2 through 7. You can write 2, 3, 4, 5, 6, 7 if you want. I'm not going to. Alright, finite set. A set that contains no elements or the number of elements in the set is a natural number. So example, 2, 4, 6, 8, 10, that's finite because we know that there's 5 things in there, and 5 is natural. Infinite sets. A set that is not finite is said to be infinite. The set of counting numbers is an example of an infinite set because we can keep going forever. We can count until the day we die. And that's what that means. Those ellipses, those 3 dots, those ellipses. I know, I purposely said it that way. It's funny. So our ellipsis is 1, 2, 3, those 3 dots. That means forever. Equal set. Set A is equal to set B. It's symbolized set A equals B if and only if set A and set B contain the same number of elements. So 1, 2, 3, 3, 1, 2, different order, but they're the same exact set, so they are equal. Cardinal number. The cardinal number of set A, symbolized n of A, is the number of elements in set A. So set A is 1, 2, 3. Set B is England, Brazil, Japan. They each have a cardinal number of 3. So they each have 3 things in it. They each have 3 elements. They each have 3 members. So we would say the number of elements in A is 3, right here. And then here, the number of elements in B is 3. Equivalent sets. Set A is equivalent to set B if and only if n of A equals n of B. So set D is A, B, C. Set E is apple, orange, pear. So they each have 3 members in the set. They're equivalent. They're not equal, they're equivalent. Equivalent versus equal sets. Any set that are equal must also be equivalent. So here, up here, that's what we're talking about. If you have 1, 2, 3, 3, 1, 2, those are equal, therefore they're equivalent. Not all sets that are equivalent are equal. So just like here, how we have A, B, C, and apple, orange, pear, it's equivalent, not equal. One-to-one correspondence. Set A and set B can be placed in a one-to-one correspondence if every element of set A can be matched with exactly one element of set B, and every element of set B can be matched with exactly one element of set A. So consider set S states and C states capitals. So set S is North Carolina, Georgia, South Carolina, Florida. Set C is Columbia, Raleigh, Tallahassee, and Atlanta. That's one-to-one because those are state capitals. Because one state, they don't share a capital, right? Like Florida and California don't share a capital. Like they have 2 separate capitals. So it's one-to-one correspondence. Null or empty set. The set that contains no elements is called the empty set or null set and is symbolized by empty braces or the little circle with a line through it. Note that if you put them together, that's not an empty set because now this set contains the little circle with the line crossed out. So that means it has a cardinality of 1. That means it has a 1 something in it. The set 0 is not empty because it contains 0. So it has a cardinality of 1. Universal set. The universal set symbolized by U contains all the elements for any specific discussion. When the universal set is given, only the elements in the universal set may be considered when working with the problem. So if the universal set is defined as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, then only the natural numbers 1 through 10 may be used in that problem. Or if you think like not just numbers, think say I asked the class like what's your favorite color, right? So then I can only collect the data of this class and use what your favorite color is. Or let's say I ask, like if we were in tables or groups, what if I asked that one group what their favorite color was? That means I can only use the data from that one group. So that's what the universal set is.